So the isosceles triangle theorem is a good place to make the distinction between a definition and a theorem. The definition of an isosceles triangle is any triangle with two equal sides, or two congruent sides, as shown in this diagram. And a very natural implication of that theorem, of that definition, is that angle A and angle C, that is the two base angles, will be congruent to one another. And so I'm going to make an argument for why this might be true, so you can push a little bit beyond just taking it on faith. Suppose we drew an angle bisector here for angle B, the vertex angle. And that would split B into two equal halves. And this part right here, it certainly seems reasonable that we would hit the midpoint and create a 90-degree or right angle, perpendicular angle. Now this part here, I'm actually fudging a little bit, but I'm not doing a full-blown proof right now. I'm just making an argument. So we draw that angle bisector, and it seems like we're going to create two 90-degree angles here. And we know that, let's see, we're going to have to label this. Let's call this point M, because it's the midpoint. It certainly looks like the midpoint of AC. And we know that all triangles, the interior angles will always sum to 180 degrees. So why don't I just add them up? Angle A plus half of angle B, because I cut it in half with the angle bisector, plus 90 degrees, the right angle down here, should be equal to angle C plus half of angle B, the other half of angle B, plus the 90 degrees from the perpendicular bisector right here. And then we can just solve that equation algebraically. Subtract off 1/2 B from both sides, subtract off 90 degrees from both sides, and all you're left with is angle A is equal to angle C. So there's one argument for the reason why the base angles of an isosceles triangle are congruent. And if you wanted to attack this argument as invalid, this is the place where you would do it. It's a little bit of a leap of faith. It's not conclusively shown that M is the midpoint and that the angle bisector of angle B will in fact be a perpendicular bisector of AC. But this is a good place to start.